Welcome back. This is the last lesson recording for IM2, January 4th, 2021. So this was the problem, the second problem that you were supposed to do. And these are my solutions. And I am showing you this because I want you to notice something. So first of all, the solution is setting up the diamond. 10 times negative 54 is negative 540. And then negative 33 is the bottom number of the diamond. And looking at all the factors, okay? Since it's a negative, you need to look for the difference of the two numbers, and one of them is going to be positive and one of them is going to be negative. So you can certainly go through it in a systematic order instead of just going through random order. That way you do not know whether you've exhausted all the numbers or not. Okay, and then you found that 12 and negative 45 is the right answer. So then you put it in here, and then you split the expression as 10x squared plus 12x minus 45x minus 54. And then you put the parentheses with the addition in between the two parentheses, and then you look for GCF of each of the parentheses, and hopefully you should get the same factors, 5x plus 6 and 5x plus 6. Then you can take 5x6 plus 6 out as the common factor, and you're left with 2x from the first half and minus 9 from the second half, and this is the factored form. Okay, now what if you split this as 16x squared plus 12x minus 45? Instead of this order, you split it as negative 45x first and then plus 12x. Doesn't matter. Are you going to get different answers? No, you're not, because once you actually factor out the common factor, you should still get the same number between the two halves, two parentheses. So 2x minus 9 is the common to both in this case, whereas before it was 5x plus 6 that was common to both. So you're going to get different factors to be common factor when you just swap this. So it does not matter whether you put plus 12x first or negative 45x first. You're still going to get the same answer. Okay, I would like you to consider these are problems that you've actually done. Okay, so this is 6x squared plus 17x plus 5. We're trying to factor. Okay, how do we figure out 17x? That's the middle term, should be split into 15x and 2x. Well, we know that because we did the diamond problem. But why can't we just use some other number? Because 10x plus 7x is also 17x, or 11x plus 6x is also 17x. Why can't we do that? Well, let's go through this. Okay, so the three different scenarios. If you're splitting the 17x as 15x and 2x as we found from the diamond problem, it works out after splitting the two halves, putting the parentheses, you can figure out that 3x parentheses 2x plus 5 is the GCF taken out from the first parenthesis. What about the second one? 2x, there are no GCF. Okay, so we leave it as that. But notice that 2x plus 5 is common to both. So in this case, although there is no number there, it does not just disappear. There is an invisible 1 there. Okay, you can think of it as 1 is being multiplied to 2x plus 5. So that means after taking out 2x plus 5, that is common to both. So you have 3x plus 1 here. Now, if we were to split the 17x as some other random numbers, 10x and 7x, what happens is you are going after splitting it into two parentheses and then finding the common factors, you are not going to get the same common factor. Okay, 3x plus 5 and 7x plus 5, they are not the same. Okay, so if you ever come to factoring and you are finding that the two factors are not the same, that means you did something wrong. Most probably the diamond problem, or maybe from the GCF step, you did something wrong there. And so no GCF to factor out, so this does not work. Likewise, 11x plus 6x, if I just randomly choose some other number, again, you're not going to have the same factor to take out at the end. So 6x plus 11, 6x plus 5, they're close, but they're not the same. Okay, close enough is not good enough in math. So 6x plus 11, so there is no GCF to factor out, so this does not work either. So make sure, okay, you are not just randomly picking some combination that's going to work. You have to go through the diamond problem and then find out how you're going to split the middle term. All right, something else, another pattern to look for. What is the pattern of product of the first and last term of the two middle terms? Okay, so once you've split, these are all the problems that we've already done during the class. Once you've split the 10x as 6x plus 4x, or negative 17x as negative 15x minus 2x, and negative 33x as 12x minus 45x, okay? We split this using the diamond problem, so we know that that is true, okay? Do you notice anything between the 3x squared and 8 and 6x plus 4x? Okay, so the product of 3x squared and 8 and 6x plus 4x. And what about 6x squared and 5 and negative 15x and negative 2x? And then last, those two. Okay, do you notice any patterns? Well, hopefully you're finding that 3x squared times 8 is going to be 24x squared. 6x times 4x is also 24x squared. They are exactly the same. Same thing here. 6x squared times 5 is 30x squared. Negative 15x times negative 2x is going to be 30x squared. And likewise here. Okay, so the answer is the product of the first and last term and the middle two terms. So if you once you have split this original expression into the middle term into two terms, two separate terms, the first and last terms multiplied should be exactly the same as the two middle terms being multiplied. Okay, that's a quick way to make sure that your diamond problem is correct. Okay, so use this fact to check your diamond pattern splitting of the middle term. Okay, so and that is it. And if you need additional support, you can certainly watch this video. And finally, what we did today, we factored quadratic expression using grouping method. That's what we covered today. Can you just make sure that you have all of this in your notebook in the table of content? Great, thank you for listening.